All right, welcome back, class. This is 8.4a, solving radical equations. We have two more lessons, and then that'll wrap up Unit 8. This will also have to do with extraneous roots or solutions. So just like back in Unit 6, where it was in the denominator, x specifically, you could have an extraneous solution, even going back to earlier in this unit. So we'll need to check for those, because when we have an even root, we cannot have negative numbers. And I'll kind of elaborate on that more. So when solving, we will be isolating for x. So earlier when we had solving equations and it was like x cubed, the inverse operation would be the cubed root. And that's because the index for the cubed root would be x to the third all raised to the 1/3 power. And then when you take a power to a power, you get 1 out because you multiply those. So that's why this is an inverse operation that simplifies it. So we're going to keep that in mind when solving root problems. So the first step we would need to take here is to subtract 5 from both sides. So we have a negative 4th root of x equals negative 5. Divide by negative 1, so the 4th root of x equals 5. So that inverse operation will be to the 4th power, and we'll want to do that to both sides. So this will simplify to just x, and then 5 to the 4th power is 625. And if we plug that in, you would have the 4th root of 625, which is positive, so that would not be an extraneous solution. So this will be pretty familiar to what we have seen. 243 divided by 3 is 81. When I break this up, I'm going to want to take and rewrite this. So that would be the cubed root, because the index is 3, the cubed root of x, all raised to the 4th power for my exponent, equals 81. Now, my first inverse operation I'll be doing is taking the 4th root. Because it's to the 4th power, we must take the 4th root of both sides. So because we have done that, we then have the cubed root of x equals, we want 4 factors. So we have 4 here. And since it was a 4th or an even exponent, it will be a plus or a minus 3. Two solutions there, because if you plug in a plus or a minus 3 into an even exponent like this, you would get 81 out. Now my inverse operation, if it's the cubed root, would be to cube both sides. So x equals, I'm cubing plus and minus 3. So we will get two solutions here. It'll be a positive 27 and a negative 27. So keep that in mind when we are solving as well. If I were to plug them in, my index is 3, so we can take the cubed root, so there are no worries about extraneous solutions here. Again, we're going to want to isolate. So start by adding 4 to both sides. So square root of 2x plus 8 equals 10. Inverse operation of square root is to square both sides. So we have 2x plus 8 equals 100. Keep going with our inverse operations. So then we have 92. Divide both sides by 2. So x equals 46. So if we were to plug 46 in under the radical, it'd be 2 times 46 is 98 plus, or excuse me, 92 plus 8 is 100. The square root of 100 is 10. So this would simplify to 10 minus 4 equals 6, and that's true. So when we checked for an extraneous solution, we got 6 out. There wasn't a negative under the radical. And let's be clear. Let's make a note of that. So if it's an even root and we have a negative number, it will be an extraneous solution. If we have an even root set equal to a negative number, that will also be an extraneous solution. So write that down and keep note of that for when you're checking. Okay, in this case, we have two roots and x is under both. So we're going to want to get them on, isolate them by themselves. So we're going to add 3 times 2, or 3 times the square root of x, and bring it to that side. And you'll see why that will help in 1 second. So we set that equal to 3 times 2 square roots of x. Now we can square, because that's the inverse operation, the left, and we must do that to the right as well. So when we square the left side, that simplifies to 1. So all that's left is what's underneath, 4x plus 28. And when we square the right, it's a product to a power, so we distribute the power to each part. So we have 3 squared times, well, just like on this side, the square root squared, that simplifies to 1, so the same would happen here, and it's times what's left on the inside. So then we can simplify 9 times 2x, which is 18x, 4x plus 28. Now we want to isolate x, bring it on one side. So we can subtract 4x, 28 equals 14x, divide both sides by 14, therefore x equals 2. Okay, so let's check. Let's plug it in. We would have 4 times 2, if I plugged x in, is 8, plus 28 is 36, square root of 36 is 6. If we plug it in here, so let's keep note of that. 6 minus, it'd be 2 times 2 is 4. So the square root of 4 is 2. 3 times 2 is 6. 6 minus 6 is 0. Good. So we verified that that is a real solution, and it is not an extraneous solution. Okay, so again, we want to get rid of the radical. So my first step is going to be to do that opposite operation. Since it's a square root, we're going to square both sides. And this will go back to unit 6. I have seen this a couple times. We're not distributing the squared through, because that's not an operation here, because we're adding. We need to expand it to x plus 2 times x plus 2 equals, well, the square root and the squared simplified, so all that's left is 2x plus 28. Now I need to distribute the left side. So when we distribute, we get x squared plus 2x plus 2x plus 4 equals 2x plus 28. Combine like terms. 2x plus 2x is 4x plus 4 equals 2x plus 28. Now that we have a trinomial here, it's a quadratic, so we want to bring everything to one side and set it equal to 0. Again, this is review back to unit 6. Plus 4 equals 28. Subtract 28. Also, I wanted to bring it to the left because we want my positive leading coefficient with my highest degree here positive. So I have x squared plus 2x minus 24. All right, and then now is where we can use the box method or our factors. So let's check. It's the AC adds up to B. A times C is 1 times negative 24. Adds up to B, which is 2. So some factors. If we think, let's see, if we do 6 and 4, we could do 6 and negative 4. Yep, that works. So then if we do the box, that'd be x squared, and then we have negative 24, and we have 6x we'll put there, negative 4x. So negative 4x, x, and 6. So that, I'm going to put it up here. Factors to x plus 6 and x minus 4 equals 0. So now we will have two solutions, and we can do mental math, or if we set them both equal to 0, we get x equals negative 6 and x equals 4. All right. Finally, we're going to want to check for extraneous solutions. So let's check for 4. If we have this equation, that would be 4 plus 2 equals the square root of 2 times 4 plus 28. So that's 6 equals the square root of 2 times 4 is 8 plus 28 is 36. So 6 equals 6. Yep. Let's check now negative 6. So that'd be negative 6 plus 2 equals the square root of 2 times negative 6 plus 28. So we have negative 4. All right. So we can already see, if we remember back, that when we have a square root, if we simplify this would be negative 12 plus 28 would be 16. We have a square root set equal to a negative number. So that tells me that this is an extraneous solution. So we can put an x through this. This is my one real solution. That's how we're going to go through and check that. All right, again, solving here. So we're going to subtract 10 from both sides. Square root of 6x minus 5 equals negative 7. There, look, already in this first step, we have a square root set equal to a negative number. So we could just stop right here and say no real solutions. But let's keep going just to see what we get. So square both sides. So we have 6x minus 5 equals 49. Add 5 to both sides. So 6x equals 54. Divide by 6. X equals 9. So let's plug 9 in. So that would be the square root of 6. 6 times 9 is 54 minus 5 plus 10. And it should equal 3. So it would be the square root of 49 plus 10 equals 3. The square root of 49 is 7 plus 10 equals 3. So 17 equals 3. That is not true. This is not true. Therefore, it is an extraneous solution. And that's why we could have stopped right here. The square root was set equal to a negative number. That's not possible. No real solutions. And to review, we use opposite operations to isolate the variable, raise each side of the equation to the same power, and check. Remember to check for extraneous solutions. All right, thanks for watching. Let me know if you have any questions, and I'll see you later. Bye.